The main parameter used to measure the effectiveness of a metamaterial polarization converters are polarization conversion ratio. So this video explains about how these parameters can be calculated from CST simulation result. First, we can analyze in the case of a reflective rotator how this polarization conversion ratio is calculated. So in the case of a reflective polarization converter, it has a metamaterial structure, and let's assume a y-polarized wave is incidenting on it. Upon reflection, it is converting into an x-polarized wave. So the polarization conversion ratio of the structure is calculated as Rxy, that is the converted wave, divided by Rxy square plus Ryy square. Ryy is the remaining wave which is in the same polarization as that of the incident wave. So if you want to do the simulation in CST, this is the boundary conditions you have to use, unit cell boundary condition. As this structure is backed by the metal plate, you can use electric along Z min, and for Z max you can use the flow cut boundaries. You have to specify distance to the reference plane here, and you have to use number of flow cut modes as 2 because we are going to consider both co and cross polar. In CST, these two modes are known as TE and TM modes. So this X and Y polarized wave has specified as TE TM in CST. That's so we have to find out that two mode responses. That is why we are using 2 here. So let's find out which mode corresponds to TE or Y polarization. So after simulation, if you go for 2D, 3D results and click on the electric field orientation, because we know that the polarization refers to the electric field orientation. So if you go here, you can see that now I'm considering for the mode 1. Here you can see that it is specifying TE mode. That means mode 1 is oriented along y-axis and it is TE. And in case of 2, if you click on E2, you can also see the orientation of electric field. Here you can see that that orientation is along x-axis and this is TM polarized. So you can use these mode values, mode 1 and 2 values for the calculation. So let's see how it will be. So after the simulations, you will be getting the results like this. So now we saw that mode 1 is Y and mode 2 is X. So here you have to find out RXY. So you know that X is mode 2, Y is mode 1. So if you want to find RXY, as we have only one port, that port will be Z maximum. So you have to put Z max, and if it is X, you have to look for mode 2 here, and if it is Y, you have to look for 1 here. That means RXY is SZ max 2 1, RYY is SZ max 1 1. And and you can use these values to calculate the polarization conversion ratio. If this rotator is the other way around, that is, if the X polarized wave is converted into the Y polarized wave, you can also do the same analysis by considering which will be the incident and which will be the reflector. So the similar case is going to happen for transmissive rotator also. In this case, we are going to consider a rotator where a Y polarized wave is incidenting on it. It is converted into an X polarized wave. So this will be the boundary condition, as we have to consider both the incidence and the transmission. We have to consider the flow cut port on both the boundary conditions, and we have to use mode 2 on both the boundary conditions. Because we know that Y polarized here is mode 1 and X polarized here is mode 2. You can use that knowledge to get the value of Txy and Tyy. So in the case of Txy, here we are considering mainly the transmission. So the transmission means Z min to Z max. That is the transmission. So if it is X, you have to put 2, and if it is Y, you have to put 1. So that is how we are calculating the Txy and Tyy. So you can use these values and make the calculations. So if you have any confusions, you can always check for the mode, that is the polarization orientation, using the 2D, 3D results, and you can make the adjustment based on that. So this is how the calculations are done when you get the result from CST. I hope you get some idea. Thank you for listening.